Data analysis using SPSS, a visual step-by-step process. Illustrative example, two-sample independent t-test by Daniel F. Sarpong. This presentation illustrates the use of SPSS as an analytic tool in performing a two-sample independent t-test via a visual step-by-step process. The content is based on a chapter extracted from the book entitled Data Analysis Using SPSS, a Visual Step-by-Step Process, Manual 1. The presentation is designed to cover the basis of SPSS and why and how to perform two-sample independent t-tests. This slide that covers the presentation outline serves as a roadmap for the presentation and is as follows. First, the purpose of this presentation is to demonstrate how one can use SPSS to perform a two-sample independent t-test by means of a visual step-by-step process. Second, the data set used is an abridged version of the Framingham Heart Study teaching dataset. The dataset henceforth is referred to as practice dataset. Lastly, the following format will be used to demonstrate how to perform two-sample independent t-tests using SPSS. First, problem statement. A problem is presented that requires the conduct of a statistical test. Next, we will state the null and alternative hypothesis. The hypothesis stated guide the type of analysis to be performed. Identification of appropriate statistical method. In this section, we covered the best and appropriate statistical method that is indicated, and in this case, it would be a two-sample independent t-test. Underlying assumptions of the appropriate statistical method. This section presents the underlying assumptions or conditions that need to be satisfied for the selected statistical method to be applicable. Visual step-by-step process of using SPSS for data analysis. We'll cover the 7-step process of successfully performing a two-sample independent t-test. SPSS output. The essential aspects of the SPSS output will be used to address the stated problem will be highlighted. Interpretation of findings using the SPSS output to cover the interpretation of the findings and appropriate conclusions. Practice dataset. This dataset was extracted from the Framingham Heart Study teaching dataset, which was created for instructional purposes. It can be obtained or was obtained from the NHLBI website, which is the National Heart, Lung, and Blood Institute. The data set contains 100 observations. The data elements are the participant ID, which in the original data set is denoted by RAN ID, gender, age of the participants, body mass index, which is BMI, measured as kilograms per meter squared, systolic blood pressure, SBP, measured in milligrams per deciliter, the diastolic blood pressure, DBP, in the same measurement units, total cholesterol, abbreviated by TCHOL, measured in milligrams per deciliter, plasma glucose, in short glucose, measured in milligrams per deciliter, diabetes mellitus, DM, and hypertension, abbreviated as HTN. This is a sample of the practice data set, the run ID, the age, sex, total cholesterol, systolic blood pressure, diastolic blood pressure, BMI, current smoker status, heart rate, hypertension, and BMI measured at a second time point. When we look at sex, it's coded zeros and ones. The zeros are females, the males are ones. The current smoking status, ones are the current smokers, and the zeros are the non-current smokers. For hypertension, abbreviated as HTN, the zeros represent the non-hypertensive individuals and one represents the hypertensive individual. The problem statement. Using the practice data set, we are to determine if there are gender differences as it relates to systolic blood pressure of the target population. The test is to be performed at a significance level of 0.05. The null and alternative hypotheses. The null and alternative hypotheses are as follows. The null states that mu sub m is equal to mu sub f, and the alternative states that mu sub m is not equal to mu sub f, where mu sub m is the mean systolic blood pressure for males, and mu sub f is the mean systolic blood pressure for females. Next, we will cover the data and information provided, basically indicating why we chose to use a two-sample independent t-test. We're using two-sample independent t-test because the dependent variable, which is systolic blood pressure, is continuous. Our independent variable, which is sex, is categorical, defined by two groups, males and females. So we're comparing the means of two groups, both of which are independent of each other. Therefore, we would use the two independent sample t-tests. The significance level, as was indicated in the problem set, is 0.05, which is at the 5% level. The hypothesis is a two-sided hypothesis because the alternative says that we're looking at mu sub m not being equal to mu sub f. So we know that they are different, but we have not specified the direction of the difference. So now let's look at the assumption. For a two independent sample t-test to be valid, the following assumptions have to be satisfied. First of all, our outcome variable, which is our dependent variable, has to be continuous. In this instance, we know that systolic blood pressure is measured on a continuous scale. The probability distribution is normal, that we have a nice bell-shaped curve. If it's slightly skewed, it still would be robust, so we could still go along with the assumption of normality. The independent variable should be categorical, and the two groups should be independent. In this case, we're looking at males and females, both which are independent groups. The observations within and between the groups should be independent, and again, we've underscored that. Typically, this is achieved if the selection of the two samples are done using a random scheme. Homogeneity of variance. The variances of the two groups should be the same. However, we sometimes have situations where the variances are not the same, and therefore another approach is used in conducting the two-sample t-test. Well, to determine whether the two variances are equal, we would then use a test called the Levene test of equality of variance. We would now discuss how we would conduct a two independent sample t-test using SPSS. To achieve this end, we first have to go to the tab labeled Analyze. We click on this tab and it displays a number of statistical analysis or methods that could be performed. For our purposes, we're interested in the option that states compare means. So what we do is we go down that menu and highlight compare means. This then opens another window menu, and under this new menu we have a number of statistical tests which compares means. We have means, one sample t-test, independent sample t-test, paired t-test, and one-way analysis of variance. As indicated earlier, our purpose is to perform an independent sample t-test. So we highlight on that and double click it. After completing steps 1 through 3, we come to this section, which we've labeled as Caption B, and that walks us through steps 4 through 7. In step 4, we basically highlighted the dependent variable, which is systolic blood pressure in yellow, and we've circled the independent variable, which is sex. So the two things we need to do is to specify the dependent variable, which in this case is systolic blood pressure, and that goes into the text variable box. And the independent variable, which is sex, needs to go into the grouping variable. So next what we do is we highlight systolic blood pressure. Using the top middle arrow, we then click on it to move systolic blood pressure from the left box to the text box. And as you can see in step 5, it is highlighted in the text box. Next, we highlight sex, and we use the bottom arrow and click it, and that puts it into the grouping variable. However, since sex has two levels, males and females, there are two question marks in the parentheses for sex. So and that is asking the question, what are the groups? So in order to define the groups, we click on the Define Groups button, and that opens another menu or window, which is in step 6. So for group 1, we indicate 0 for females, and group 2, we indicate 1 for males. And then after we've completed that, we click the Continue button, and that now moves us into step 7, where we now have the systolic blood pressure in the text box denoting our dependent variable. Our independent variable sex has now the groups defined, which is zeros and ones, in the grouping variable. After completing that, we're now ready to execute the t-test. So we click OK, and that now concludes the independent sample t-test and generates the necessary SPSS output that we need. The SPSS output for the independent two-sample t-test is displayed using two sets of tables, the group statistics table and the independent sample test table. From the group statistics table, we realized that the mean systolic blood pressure for females was 136.98 millimeters of mercury with a standard deviation of 20.501 millimeters of mercury. And the males had a mean systolic blood pressure of 130.76 millimeters of mercury with a standard deviation of 16.461. The mean difference, which will be compared to 0 using the t-test, is 6.219 millimeters of mercury. From the independent sample test table, we realize that there are two approaches by which the t-test allows us to be able to test the hypothesis at hand. One approach assumes that the variances of the two groups are equal, and the other assumes that the variances of the two groups are not equal. To enable us to select the right test or the right approach, be it equal variance t-test or unequal variance t-test, we would need to look at the Levine test of equality of variance. So next, let's step back and ask the question. Remember that our hypothesis that we're testing, the null says that the two means systolic blood pressure for females and males are the same. The alternative is saying that they're different. So for us to be able to address that hypothesis or test that hypothesis, we would need to select the appropriate t-test. To do that, we would need to first look at the Levene test of equality of variance to determine whether the variances are equal or not. The null hypothesis associated with the Levene test of equality of variance is saying that the variance of systolic blood pressure in the males is the same as that of females. The alternative is saying that they are different. When we look at the Levene test, the p-value associated with that test is 0.003, which is less than 0.05. Therefore, the test is significant. Hence, we're going to reject the null hypothesis and conclude in favor of the alternative, which says that the variances are unequal. So from this point on, we know that we're going to use unequal variance t. So now that we have determined that we would use the unequal variance t-test, we now revisit the main hypothesis. That is to look for gender differences between the males and females as it pertains to systolic blood pressure. So again, let's revisit our null and alternative hypothesis. A null hypothesis states that the mean systolic blood pressure of the males are equal to that of the females. The alternative is saying that the mean systolic blood pressure of the males is not equal to that of the females. Now, since the p-value associated with the unequal variance t-test is 0.151, which is greater than 0.05, we say that the test is not significant. Hence, we fail to reject the null hypothesis. Therefore, our conclusion would be that there is no significant gender difference in systolic blood pressure for this target population. Well, this practically concludes how you would conduct a two-sample independent t-test. For more information on a visual step-by-step process of using SPSS to perform most of the commonly used statistical methods, you can visit Amazon.com to get your copy of the book entitled Data Analysis Using SPSS, a Visual Step-by-Step Process, Manual 1 by Daniel F. Sarpong. Thank you.